At the outset, uh, I'm thankful to the organizing committee members of Canoism's 8 at Jigmer Pondicherry. It's a wonderful event, and I thank you for the opportunity given to me to share research idea. As the title reads, the idea is all about designing a solar reactor for producing hydrogen energy at an accelerated rate by the fermentation of carbohydrates. As can be seen, the theme for Inventio research idea presentation is time critical where innovations where minutes matter. And our idea is focused on urban and rural healthcare delivery. The audience might be very surprised that how this particular title fits into the theme and sub-theme. I want to clarify that our presentation or our idea is not out of the odd man out or not fitting to the scope of the meeting, as the visionary selection committee has rightly selected me to present my topic, even though it appears to be an odd man out. Basically, my focus is on prevention is better than cure. So many respiratory diseases, so many lung related diseases, so many sicknesses are originating from poor air quality. Air pollution, water pollution, soil pollution, these are the chief sources of sicknesses, and many of these diseases which are lethal, which are causing life threat, can be surmounted, solved, provided we switch from fossil-based economy to hydrogen-based economy. Our fuels should be more clean, more greener. In this perspective, I want to say that the hydrogen fuel appears to be the best choice. Hydrogen is the future fuel. For example, the coal reserves what we have will be lasting for 140 years more. So by next century or towards the end of the next century or towards the second half of the next century, our thermal power plants will be having a totally new supply of energy source. Our thermal plants for generating electricity will be relying not on coal but on a differently new energy source. So the focus should be to prepare us for future. At this juncture, I want to tell that hydrogen energy is the future energy. Hydrogen energy has the energy density value which is 2.6 to 3.1 times higher than whether it is gasoline or petrol. So the energy density is higher. You can see in the periodic table, hydrogen appears to be with atomic number 1. Hydrogen is the lightest material. So this means that hydrogen is very lightweight material with very high energy density. So this is the ideal fuel for our transportation sector and our industry and for house and domestic applications also. Herein, I want to propose a solar reactor wherein we can use a variety of carbohydrates like glucose, starch, cellulose, algal biomass rich in starch, rich in cellulose, for converting them to hydrogen by fermentative bacteria that lead to conversion of glucose to hydrogen. That is one aspect. Apart from this, we can also think of algal biomass like Chlamydomonas reinhardtii. It's an algal biomass, but it's a microalgae. This Chlamydomonas reinhardtii has a special feature. It has a hydrogenase enzyme. It has iron containing hydrogenase enzyme inbuilt in the microalgae, so that what will happen is it will evolve, it will emit hydrogen during the course of its growth, during the course of various metabolic pathways, during the photosynthetic process, and the production of hydrogen will be 2H plus 2 electrons gives rise to H2. Okay, H plus, the protons will be reacting with the electrons that are generated within the system in photosystem 1 and photosystem 2, and H2H plus 2 electrons gives rise to H2. It is not metabolizing the glucose. It's not metabolizing the carbohydrate that is present in the algal biomass Cladomonas reinhardti. That is totally different. It has an inbuilt iron hydrogenase enzyme. This iron hydrogenase enzyme, what it will do is it will convert H plus to hydrogen via photons, via photosynthesis process. Okay, ma? As the algae grows, within the system there is hydrogenase enzyme. That hydrogenase enzyme converts H plus to H2. This is altogether a different approach. So what I mean to say is, in our solar reactor, per se this is the solar reactor. Okay, in our solar reactor there is a fermentation chamber. Okay, ma? In this fermentation chamber, we will supply carbohydrate to the reactor. Carbohydrate. It can be glucose, it can be starch, it can be cellulose, it can be algal biomass rich in starch and cellulose, like Ulvaricta, like Chlorella vulgaris. Okay, this fermentation chamber contains some bacteria that can metabolize carbohydrates to hydrogen. I will in the next table show a series of fermentative bacteria that will convert carbohydrate to glucose, and from that table I will show which is the best bacterial species that we can use for our reaction. Okay, the idea is all about constructing a solar reactor made up of carbon fiber reinforced composites. Why carbon fiber reinforced composite? Because there has been enormous amount of work done by my mentor, my supervisor Indranil. They have developed a solar reactor and used it for the production of bioethanol. Here, instead of yeast, we will not put yeast that will convert glucose to ethanol. In the place of yeast, we will be using a special bacteria that will metabolize glucose to hydrogen. That is the only difference. That is the only difference. Another important difference is the reactor. So my mentor used is made up of aluminum metal. It's very heavy. Okay, it's very heavy, and it causes serious concerns regarding environmental pollution, because aluminum metal we are getting by digging, okay, by mining. So if we move from aluminum based solar reactor to carbon fiber composite, carbon fiber reinforced composite, అది ఎప్పుడు ఇరుకోనా carbon fiber reinforcing అంటే ఏంటంటారమ్మా, we take carbon fiber towels. This carbon fiber towels can pitch based carbon fiber towels or polyacrylonitrile carbon fiber towels. Japanese company is the expert in selling the carbon fiber towels. Okay, the pitch based carbon fibers from petroleum refinery operations can be taken. It can be mixed with polymers like several biocompatible polymers, and then the carbon fiber reinforced polymer can be prepared, and it will be very light in weight. The reaction will be very light in weight, it will be strong, it will be sturdy, it can withstand high temperatures, it can withstand up to 40 to 50 degrees centigrade, and also it can long, it will have durability, it will not have breakages. Okay, so we need not spend our money again and again on the infrastructure. So basically the reactor is proposed to be made up of carbon fiber reinforced composites to increase the durability. One more important application of this carbon fiber reinforced composite is the black in color. Black in color means it is an ideal absorber. It can absorb more solar energy, the solar energy, the heat energy, the photons, the light. On the reactor, the transparent polymer will be there. Okay, the transparent polymer as shown here. This is the reactor. Okay, ma. Here, instead of yeast, we are going to take bacteria strain that will metabolize glucose. Glucose will be sent from here. Glucose reservoir is like this. This is the glucose reservoir. We are passing glucose into this, and this is the fermentation chamber. In the fermentation chamber, so far we produce bioethanol. What we say is, if we take glucose and if we put fermentative bacteria that will convert carbohydrate to hydrogen, not ethanol. Okay, that particular hydrogen can be collected at the bottom by the downward displacement of water, a downward displacement of water. You see, where is the reactor? Yeah, this is the reactor we are talking. This is the design of the reactor. There will be a reservoir of glucose from here. Glucose will be passed into the reactor, and this is the fermentation chamber where the carbohydrate is converted to hydrogen, and this is airtight. The reactor is airtight. Okay, only the outlet will be connected. The outlet is for taking the hydrogen gas out. The gas that is formed will be collected at this, and the outlet is connected to the trough. It will be immersed in a cup with the water, and it will be connected to a measuring cylinder from the bottom. Okay, from the cylinder the water will be displaced downward as hydrogen is going up. So the amount of water that is displaced is a measure of the hydrogen that is formed per minute. Per minute, how much hydrogen is formed we can measure. Okay, per minute maybe 100 ml, 200 ml. Depending on the displacement of water, we measure the volume in the cylinder, and from that we can know which is the best bacteria strain, what are the best optimized conditions for the conversion of glucose. So we propose for the first time that such a solar reactor can be fabricated using carbon fiber reinforced composites. Carbon fiber reinforced composites are the advanced polymeric materials nowadays. All the infrastructure, for example, marine infrastructure where ships are made. Instead of iron, instead of metal, they are making the ships with carbon fiber reinforced composite, because in the carbon fiber reinforced composite, carbon fiber is the main load bearing component. It can withstand very, very heavy weights. We need not have iron rods. These carbon fibers are so graphitic they can withstand high loads. Okay, ship it very weight, you know. Moreover, these carbon fiber reinforced composites are very light, unlike metal, unlike iron, or unlike aluminum. So what we propose is we propose a robust carbon fiber reinforced composite reactor made up of, which is very light in weight. Okay, so it is for decentralized applications for urban population as well as for rural population. This can be scaled up. This can be scaled up, and the hydrogen that can be obtained, the hydrogen that is obtained can be connected to a fuel cell. The hydrogen that is obtained can be converted to fuel cell. Fuel cell is a device where the chemical energy is converted to electricity, and we can generate our electricity for our home needs. That will substantially reduce the electricity that is generated from coal-fired power plants, and that will reduce the minimize the use of coal. Okay, ma'am. So, yes, this is the perspective. Okay, this is from these words are borrowed from Kwasi Hassan. Kwasi Hassan, and this particular paper is published in International Journal of Hydrogen Energy. The development of sustainable energy sources has become a major challenge for society. Okay, what are the sustainable energy sources? Green hydrogen. What is green hydrogen? Green hydrogen is a hydrogen fuel wherein the energy that is used for the electrolysis of water also comes from renewable energy sources like hydrogen, photovoltaic cells, wind, thermal, geothermal. So such green hydrogen produced through electrolysis of water using renewable energy sources offer a potential solution to reduce our dependence on fossil fuels. If we can produce green hydrogen using such solar reactors which are integrated with solar energy, that will substantially reduce our dependence on fossil fuels, and so the accumulation of CO2, the accumulation and buildup of nitrogen oxides, sulfur oxides in the atmosphere will be substantially reduced, and it will have a sustainable future, a clean future, a green future. Okay, then the paper, that is this paper proposed by, I will read it. Examines the integration of green hydrogen into various sectors, like how the green hydrogen can be used in the transportation sector, industry, power generation. This is what I exactly say. Now the power is generated by coal. After 140 years there is no coal. How the power is generated? We use instead of coal, hydrogen, because hydrogen has an energy density how much? 1.6 to 2. 1 second. 2.6 to 3.1 times. 2.6 to 3. Nearly 3 times higher. 3 times higher in an episode already. 49 megajoule per kg gasoline. The same thing, if you use hydrogen, it will be 150 megajoule per kg. Kg of fuel to 3 times higher energy output further. So what will you prefer? Hydrogen. The question is it marketed? Is it commercial? Now, in India it is not commercial because the cost of green hydrogen is prohibitively high. The cost is now $10. Unless we cut short the price from $10 to $1, $1 is nearly 92, it will not be realizable. In Germany, it is produced for $5 per kg. So Germans are substantially reducing the price. You can see in the slide here. Yeah, this is to show the publication trends. As you can see here, during the past decade there has been a steady increase in the number of publications in green hydrogen, and in 2024 there are 6,000 papers per year. Okay, it's steadily increasing, and this shows the standard of United States Department of Energy. The United States Department of Energy shows that using ammonium borohydrates as high as 25% gravimetric hydrogen can be stored. Okay, this is the chart showing the maximum hydrogen that can be stored gravimetrically. The ideal candidates are ammonium borohydrates. Okay, this is the ideal region. This is the target. X-axis on the 25 weight percent hydrogen. To achieve 25 weight percent hydrogen storage, what is the material? Ammonium borohydrate, NH4 BH4. இது பாருங்கம்மா, நீங்கள் வந்து அப்படியே காப்பி பண்ணியிருக்கீங்க. இப்படி இருக்கக்கூடாது, இது தனியாக காப்பி பண்ண. எப்படின்னா பாருங்க, இந்த பவர் பாயிண்ட் பாருங்க. இது எடுத்துருக்கீங்களா? சொல்ல இருங்க, இது எப்படி காப்பி பண்ணான்னு சொல்றேன். கிளிக் பண்ணிட்டு கண்ட்ரோல் A, கண்ட்ரோல் C. பாருங்க, இங்க வந்துட்டு இப்போ பாருங்க, இது delete பண்ண முடியல.
ஓகே,
நீங்க எப்படி காப்பி பண்ணிருக்கீங்கன்னா அவ்வளவுதான்.
ஓகே சார்.
This is what I said, amma.
Okay. So I thought you wanted the whole slide.
Whole slide the copy பண்ணிட்டு whatever is needed we can put here. Whatever is not needed you can delete.
Control A and Control C.
அவ்வளவுதான். இது பாருங்க, இங்க வந்துட்டு இப்போ இந்த பிரசன்டேஷன் ஓபன் பண்ணுங்க. அடுத்தது this Control A, C. Okay. That's all. What is so big in this?